the design patterns is our opportunity to collaborate, interact, gain knowledge, and today we are going to see and feel how the training course is going to be like. With that, let's begin. At the end of this session, we should be able to understand and appreciate the need of design patterns. We should be able to build some flexible design using a select design patterns. So let's understand what a pattern is. When you're seeing my screen, you will see there are some diagrams in a sequence, and some of us might have played with these kind of questions and trying to figure out what is the next number or diagram or an alphabet. This is a very general problem statement in the world of aptitude tests, and this is how and therefore ability to figure out the pattern is a crucial one. Now the pattern that we have on the screen, here is a solution. One of the characteristics of the pattern are that they are easy to recognize, right? And we see them all the time. We just need to observe and you will see the patterns in the real life everywhere you look at it. And that makes them very powerful because they're observable, easily observable. The other people can also appreciate it and deduce certain logic based on it. Moreover, patterns come in handy because they are answers to some recurring problems. And because the problem is recurring, its best known solution, that is pattern, is also recurring. So you will see the yellow highlighted numbers or diagrams are the next in the sequence because we were trying to identify a pattern. Since all of us here are some sort of software developers, the next question would be, are there patterns in the software development? There are problems in the development. Can we figure out some recurring solution to these problems? And the obvious answer is yes. And it's not only just plain simple yes, it is, oh, definitely yes, and we should consider using those patterns. Because they are recurring solutions, they are very well understood by the industry, and industry has also analyzed them for their weak points and the strong points. Where should we use them, the context of the problem and the constraints, that is, what can we do or not do with those patterns. Here comes our pioneers in the space of design patterns. They're called Gang of Four, and they were one of the first ones to catalog the design patterns. Now note this, these Gang of Four guys did not invent the patterns. They just analyzed the existing systems and draw commonality and catalog them, that is, listed them as the design patterns. And it was a groundbreaking book, the one that they wrote, because it changed the way we think about softwares, and we then started saying, okay, so if we know the problem statement and if there is a match, we can very well pick up a design pattern from the catalog and solve the problem. And we don't have to bang our head to figure out how do I solve it and also meet all the constraints and make it maintainable. So before I move on to the next slide, note their faces, how happy they seem to be. So importance of the design patterns. Well, one of the most important part in design patterns is industry experts understand them, and so can your and my peers, and it brings up a common language for people to talk to each other when they are talking about software development. They also are based on, in recent times, something called object-oriented programming paradigm, which is the most popular methodology of developing the software. But it also comes with a downside. A downside is that many programmers and sometimes even designer falsely assume that design patterns and object-oriented paradigms are one and the same, but they are not. In general, patterns and then design patterns have nothing to do with a specific kind of programming paradigm, in this case object-oriented. Because object-oriented is more prevalent, therefore the design patterns for object-oriented world are more prevalent. Most importantly, these design patterns are tried and proven solutions to programming problems, the problems that recur. And if we choose to implement a particular design pattern to solve a particular problem, it guarantees us that the next person who's going to maintain the code understands it, because they will be able to understand the design pattern. And we also know the weaknesses and strengths of those design patterns. So should the context change, we will be re-looking at the design pattern and say whether it is still okay to use, or should we switch it to or swap it out in favor of another design pattern. Today we are going to look at a use case, a problem statement. We're going to say that let there be some sort of factory, a factory which consumes the raw material and produces the finished good. That factory could be a cement factory or a pickle factory or a cheese factory, even a chocolate factory if you like. The factory is going to get some material, some raw material. There would be some automated machines that keep track of the speed, the temperature, the ingredients and all. And the data is captured using sensors, various sensors employed in this automated system, and these sensors are going to send their input to the master control system. The master control system will look at those sensor values and operate on the data, decide what action to take, and then action is relayed to something called actuators, which may change the temperature or may change the mixture proportion. These machines operate in coordination. If one of the part fails, the operation is cannot be completed. So there needs to be communication between these entities in your factory. For example, a temperature sensor talking to the master controller, and master controller talking to maybe a furnace, an electric furnace, to either lower the temperature or increase the temperature. A real world scenario question will be, how can we build this automated system? So we'll continue with this use case and requirements. We are saying that let there be different entities that are monitoring data generated by the sensors. Each entity can take its own decision on data as well as inform to other. For example, a temperature sensor may display it to a human operator as well as send that data to the master controller. And there is a master management control room where the commands to different entities are generated, which is solely responsible for the good and safe operations. And the data from the entities is also sent back to the master management control room, where it is processed and actions can be taken. In some cases, even the audit logs can be generated. With that, moving on, here is the general depiction of how the solution would look like. There could be packaging entities, the master management control, the catalyst control, and the chemical control entity. And you see these blue diamond, they are actuators. So all these bubbles are gonna operate on actuators, and these yellow rectangles are sensors who are gonna send data to these bubbles. If you look at it, the master management control is a central entity which is responsible for the operation of this factory. There are the three other entities which are separate domains, some handling chemical composition, catalysts, and packaging. But it is the master management controller system which orchestrates various operations in this. So this is going to be a general depiction. We will then come to how a non-object oriented world can program it. They will probably go by procedural system, and they will put all the functionality pertaining to management control into something called a main function. And then main function may have certain other helping procedures or child procedures, subroutines, which allow main to segment its works. Well, it may solve your problem, but it may be hard to maintain. What happens, for example, the catalyst composition needs to change. You'll have to figure out the exact procedure where it needs to change, go update that procedure, recompile your code, test it out, and then deploy it into a production system. Now, the challenge here of the procedural system is that it thinks like human brain. You know, I walk up the stairs. If I need to go to, let's say, a third floor, I know that I have to walk up to the base of the staircase or at the elevator area and do a next step, maybe start climbing up or requesting the elevator based on what we chose to do, and so on and so forth. Essentially, a procedural language is more like one looking at it from a single point of view. In this case, if a human needs to go to a third floor, a human will start thinking what he needs to do and not what needs to happen in the environment that he is living in. Such procedures would be good if you are building a very small application, maybe something that accepts the data in the single form in a web UI. But this cannot scale when we are talking about complex enterprise-wide applications, especially those applications which are to be maintained for, let's say, 5 to 7 years. In fact, what ends up happening if you write procedural programming there is you write a lot of spaghetti code. And therefore, in general, one would want to move into the object-oriented paradigm where each entity is represented by an object or set of objects, and that allows you to maintain the program in the long run. Here comes the object-oriented world's kind of introduction. With any technology, it's not going to solve all your problems just by using it. One has to be a little more intelligent as to find out how to use it. There is an old saying which goes like, the one who has a hammer thinks that every problem or everything is a nail. We will be doing good if we remember that we don't own a hammer, and if we own a hammer, not every problem is a nail. You don't have to use the same old stuff to solve any new problem. Then what problem should we be solving by having that hammer, or in this case having some known solutions? That's where need of understanding design pattern comes in. So let's talk a little bit about object-oriented on the slide. An object-oriented programmer may take a master management control unit in one object, and subsequently different entities are different objects, and one would want them to talk to each other to achieve certain use case. So as rightly noted there, once we have identified the objects, the only remaining part is to find out how they will talk to each other, communicate to each other, to achieve a same common goal, in this case the use case that we talked about. When we look at it, we definitely know that there is something missing. And what is it missing? Well, how about a change required because there is a new research coming in? Or how about I want to scale up my application? In this case, for example, I want to increase the unit production per day of my factory. In a software world, that will mean how can I make my application run faster? And most importantly, which is the life of any software, it has to evolve because the business needs change. And sometimes we add functions or features to the existing software. Let's say in case of a cement factory, I want to change my packaging from a 50 kg bag to maybe a 10 kg bag. And I also want to, let's say, change the material of the sack in which my cement gets packaged in. So in the life of a software, it is important to understand initially that a code needs to be maintainable. If I may share with you some statistics, it is very likely that a software application will spend 80% of its lifetime in the maintenance mode, where you're just making sure that the software survives in the production. Perhaps we spend about 10 to 12% of the time designing a system, and only maybe 8% time to write the code and test the code. And therefore, while building any system, one has to also consider what does it take to maintain it. And that is where, if you know the design patterns and if you apply them correctly, the answers will come naturally. Every design pattern will have, as I said, its own strength and weakness. And what matters in the maintenance mode of a software is how do we cope up with the weakness of any system. So as I said, the design patterns are kind of cataloged, right? And if you know the design pattern and if you know how to use it, you would be a better software developer. But there's a difference between knowing what a pattern is and knowing how and when to use it. If I may draw your attention to a difference between a knowledge and a wisdom. In knowledge, we'll say, oh, there is a design pattern catalog wherein there are patterns XYZ and it is to be applied in certain cases. But it is the wisdom which will tell you when exactly to use it, when you should not be using it. And generally that comes with experience. And I'm here with you to share that experience and some sort of wisdom. There is an old saying, if I may quote it here, knowledge is like knowing that tomato is a fruit, but wisdom is knowing that it is not to be put into a fruit salad. So if you look at a design pattern catalog and you find out, oh, well, there is an Abstractfactory, but if you don't know when and how to use it, that knowledge is not really useful, isn't it? You'll probably be creating more mess than you started with. And that's where we come in. We want to share with you the experience that we have in industry and knowing, for example, an Abstractfactory. What is it and how to use it and what is the consequence of using it in the maintenance mode. So with that, I am moving to the next slide. We're saying that we will model this manufacturing entity with some design patterns. For example, if you don't do it with design pattern, it will work. But then in future, when you want to extend the functionality or make it more maintainable or scalable, it will be a hard task to take up. So one also have to understand, okay, most of the time we think about building a new software. Have we thought about when the software dies? Well, I can tell you that a software dies, meaning the software is taken out of production, when it is no longer economical to maintain it. The code has become something called a spaghetti code. The original developers who developed it are no longer with that organization, and the new developers did not perhaps got the entire KT, or did get the KT but did not get their facts together, and it is cost prohibitive to add feature to that software. In such cases, the architects and the business stakeholders will want to think about building a brand new system. And if the brand new system is not developed well, the cycle repeats. Very soon the software will age. It is not beneficial to maintain, or it is a cost prohibitive to maintain that system in production. And then architects and business holders will come and say, oh, they want to build a new system. So using the right solution, in this case right design patterns, extends the life of the system. And that's where it is important for us to know the design patterns and know how to use it, not only for the fresh or greenfield projects, but also for the projects under maintenance. Design patterns are generally a common language between the development organizations. For example, if you are building an Abstractfactory pattern, somewhere in the comments you will say that, well, this is a standard Abstractfactory pattern, and let's say 3 years, 4 years down the line, somebody wants to come in and in the maintenance mode, enhance it, or kind of make some changes because of maybe a business scenario changing. The person will read Abstractfactory pattern, he'll easily be able to correlate the related classes to those entities in the Abstractfactory, or any other pattern for that matter, right? That makes it very maintenance of a large enterprise scale applications moderately easy to maintain. Now, because design patterns are proven solution, you also know the consequences. Should there be in the maintenance mode, should there be a added requirement to a scenario which makes that design pattern not so lucrative, one will have an option of swapping out that design pattern in favor of some other design pattern which makes more sense. And that's where it's very important to understand how to use design patterns.